Ellie here, and I'm going to tell you about the acidification of the ocean. In simple terms, the ocean is becoming more acidic, which means its pH is rising. The pH scale is logarithmic and spans from 1 to 14. Baking soda is basic and has a pH of 9. Battery acid is acidic and has a pH of 1. Water is neutral and has a pH of 7. In terms of chemistry, on the molecular level, pH stands for potential hydrogen. If we look at a water molecule, an oxygen has 2 hydrogens attached to it. Oxygen has 6 valence electrons and shares 2 of them with hydrogen atoms. If another water molecule gains this hydrogen, it becomes H3O positive, or hydronium. This positive ionic charge occurs because in order for the molecule to have a full electron shell, a negatively charged particle must be removed. The number of these hydroniums and hydroxyls determine the pH, and these, hydroniums, are what cause things to be acidic. Since the pH scale is logarithmic, something with a pH of 3 has 10 times more V's than something with a pH of 4. This is a significant part of the change in the ocean's chemistry, as 200 years ago, the ocean's pH was around 8.2, but today it's around 8.1 according to the Smithsonian. Clearly, the number of V's is increasing, but how? Well, it has everything to do with the concentration of carbon dioxide in the atmosphere and the fact that 30% of this stuff is absorbed by the ocean, according to them. But where is this coming from? Sources include 1, the burning of fossil fuels, which produces tons of carbon dioxide, and 2, deforestation. But how is this getting into the ocean? Well, CO2 is a gas soluble in water. The solubility of gases increases with the decrease of temperature. So, more CO2 can dissolve in colder waters. What does this do on a molecular level? The decrease in pH indicates an increase in acidity. So how do these ions form? Carbon dioxide and water mix to form carbonic acid. This carbonic acid then breaks into H+ ions and bicarbonate ions. These reactions show that carbon dioxide in the ocean leads to carbonic acid increasing, which then dissociates into H+ ions, increasing ocean acidity. The issue with ocean acidity is that while the number of bicarbonate ions increase, the number of carbonate ions decreases. What are carbonates? Well, they occur naturally in Earth's crust and can be found in marble, limestone, and chalk. They greatly impact the shells of isopods who need these ions to build their shells. With ocean acidification, the acidity can be corrosive to their shells, on top of the great impact it has on the shell building process. To oversimplify the shell building process, ions, such as carbonate, need to pass through tissue so they can be deposited and then calcified or hardened to form the shell. When the carbonate levels decrease, these animals have to direct more energy to building their shells, rather than other activities such as reproduction and feeding. This can impact their populations, which in turn impacts entire food chains. While ocean acidification is impacting the populations of shelled organisms, some good news is that this issue is being studied. The BioAcid project allows scientists to study acidic water. Giant test tubes that can hold 15,000 gallons of water were placed here. They were sealed and their pH was decreased to 7.8. This will allow scientists to observe the impacts of rapid ocean acidification.